If you need a program to help calculate sales data, one approach is to manually copy each data entry from the data file into the code and then run the program to get the result. If you have multiple market data files from different dates, you would have to keep modifying variables in the program, which quickly becomes inconvenient. But once you learn how to work with files, the same piece of code can read different market data files just by changing the file name, which is much more elegant. The first step in reading a file with Python is to open the target file. We use the open function and pass in the file path, which can be either a relative path or an absolute path. If you're not familiar with path, you can review the previous video. The second parameter is the mode, which is a string. Common modes include R for reading and W for writing. Since this video focuses on reading files, we use R. This parameter is optional if omitted. The default mode is reading, in read mode. If the program cannot find the file you specified, it will raise a file not found error, indicating that the file does not exist. The open function also has an optional parameter called encoding, which specifies the character encoding. Nowadays, most files use UTF-8 encoding, so passing UTF-8 will read the file using that encoding. If open executes successfully, it returns a file object, which can then be used for reading or writing operations. For reading files, the file object provides a read method. When called, it reads the entire file at once and returns the contents as a string. In general, the file formats we work with in code are usually simple and straightforward. For example, plain text files like TXT are ideal because their contents can be easily converted into strings. Formats like Word files include fonts, colors, and styling, which often cause problems when reading them with code. Another thing to note is that if you call read a second time, it will return an empty string. Because the program keeps track of the current read position in the file, the first call reads the file to the end, so there's nothing left to read on the second call. For very large files, it's best not to use read because loading the entire file into memory can consume a lot of memory or even cause memory issues. If you don't want to read the entire file at once, you can pass a number to read, specifying how many bytes to read. The next call to read will continue reading from where it left off. Besides read, we can also use the readLine method to read files. This method reads only one line at a time, and each subsequent call reads the next line. It determines the end of a line based on new line characters, and the new line itself is included in the returned content. You might wonder, if a file has many lines, how do we know how many times to call readLine to reach the end? When readLine reaches the end of the file, it behaves like read and returns an empty string. That's why we usually use a while loop. As long as the returned string is not empty, we keep reading, otherwise we exit the loop. If reading line by line feels tedious, there's another method called readlines, which simply adds an S to the name. Readlines reads the entire file and returns a list of strings, with each element representing one line. It's commonly used together with a for loop. You read all lines first, then iterate over them one by one. At this point, we've learned 3 ways to read files, and you can choose the most appropriate one depending on the situation. After finishing reading a file, there's one more important step: closing the file. File objects have a close method. As the opposite of open, calling it releases system resources, so files should always be closed after reading or writing. Sometimes we might forget to call close. An alternative approach is to use the with keyword. With with, you call open. Use as to name the file object, and place file operations inside the indented block. Once the block finishes executing, the file is automatically closed. This approach makes the code cleaner and eliminates the need to call close explicitly. Now it's time for practice. Since we want to practice reading files, let's first create a file to read. As mentioned earlier, code is best suited for reading plain text. To create plain text, you can use Notepad on Windows or TextEdit on macOS. But an even simpler way is to right-click in the code editor, select New File, enter a file name, and use the file_txt suffix here to indicate it is a plain text file. Then write a few lines of content here. I'll just copy a random poem. Note that the file's location determines the path we need to input when reading the file. This file is currently created under my project folder. Now, back to our Python program. Before reading a file, we need to open it, so use the filepan_sendoutPen function. This function is built into Python, so no import is needed. The first parameter is the file path. For simplicity, we can use a relative path. A relative path is relative to the current code file I am editing, where the file we want to read is located in relation to it, since the file to be read and the code file are in the same folder. The relative path is quite simple. It uses a dot to represent the current folder, followed by a separator. Note that on Unix-like systems, the separator is a /add, while Windows uses a backslash after the separator, add the file name. This indicates that the file to be read and the code file are in the same folder. The second parameter is the mode. Since we are reading the file, the mode is file. But this can be omitted because the default is FINE_WHILE anyway. We can also add the optional FINE_ENCODING_1 parameter. The default FINE_ENCODING_1 in the function follows the system, so it is better to explicitly specify encoding -8. The FileWeapon function will then return a file object. Let's name it TOFFI stands for file. Once we have the file object, we can start reading the file. The most straightforward way is to use the file reading method. It returns all the content of the file as a string. So here, we can first store this content in a variable, then print it to C. Finally, remember to call cycloc to close the file and release resources. Now we can run it to see the result. As you can see, with just 4 lines of code, the entire file content is printed, matching its original content. Sometimes we might forget to call file close C, so we can also use while with for to avoid needing to manually close it. So here it would be switch_with_open as FL. Remove the for and close line, and ensure all file reading operations are indented under it. Run it again, and you'll see the result is exactly the same as before. Besides our while, we can also use while readline to read line by line. For example, if we call file readline twice, it will read the first 2 lines of the file. Also, note that all operations on this file object must be indented under with wait. If the second line isn't indented and falls outside the void block, by the time it runs, the file object would already have been automatically closed, resulting in an error. Let's fix the indentation and run it again. Another thing you might wonder is why using file readline produces extra blank lines. The reason is that tar_readline reads the new line character at the end of each line as well, and the for_print_for by default adds a new line at the end. So the combination of 2 new line characters creates an extra blank line. The third reading method we'll learn is file readlines. Let's print it directly to C. You'll notice it returns a list where each element is the content of a line. Here, we can clearly see that the new line characters at the end of each line are also read in as part of the file. Typically, file readline C is used with a for_sweep loop. We can first assign the read content to a variable, then loop through this list. Use it to print each line's content. You'll see the effect is also to print all the content of the file. See you in the next video.